University is presenting you the next generation Mars Rover for University Rover Challenge 2016. The following presentation will describe every module that we spent months to develop.
So we have built a 6-wheeled Mars exploration rover. In our rover, we have used a modified version of BRAC 2 suspension system. In this system, we have 2 parallel bogies which are connected through an articulated rocker. A differential mechanism between the left and the right suspension levels the pitch angle of the main chassis. In this design, the front and the back bogies are identical. The rocker which connects both bogies have a rotational joint in the middle. Thus, our design is fully symmetric. The load is distributed evenly on all the wheels.
We are using 6 high-torque DC wiper motor generally used in automobile windscreen. Since we don't have custom-made motor in our country, so we did some reverse engineering. We have designed our own shaft which increases the performance and the strength of the wheel. After the modification, the rotational speed of the motor is approximately 1.3 radius per second. The maximum forward or backward speed of the rover with no load is approximately 1.5 km per hour. Our wheel with a diameter of 12 inch consists of 2 steel rings containing rubber strips. Extruded rubber grips have been used at equal interval for slightly rocky surface. To reduce weight while performing tasks with arm, we will remove 2 wheels and 2 motors. Then we intercept the middle part of the bogies through a thick bolt and double nuts. Thus, the rover becomes 4-wheel.
The arm for this rover has been designed with 5 degrees of freedom. The lightweight rotational system allows the base of the arm to rotate up to 110 degrees sideways. The rotation is driven by an actuator. The arm consists of 3 actuators and 2 DC motors, giving a huge working area to the arm. The arm ends with an end effector 3-fingered claw at the tip. First, the claw was actually designed for 2 fingers, but we did some modification and made it 3-fingered. The extra grip in each finger helps the rover to grab small stuffs more perfectly. The claw is controlled by 2 DC motors. One is for 360-degree rotation and one is for grabbing.
We have designed our rover electronic circuit more functional and more modular in such a way that we can replace it in any emergency case. We are using 6 wiper motor and it draws 9 amps, so we are using high amp motor driver circuit which is 13 amps and operating voltage is 24 volt, and also we have made our custom made motor driver circuit with industrial relay and power MOSFET with PWM control. Initially we are using 24 volt lead acid batteries for our motors, and we have also LiPo batteries for powering our other modules like NAC-PC, the communication router and other science touch modules. Finally, we are using a kill switch to stop our rover in any emergency case.
Many outdoor routers have more than 5 km range. We are using point-to-point communication to establish a strong network. We are testing our signal strength and coverage area, and the result is pretty good.
For controlling, we are using onboard Intel NAC-PC with Arduino microcontroller. 2 different thumb joysticks are used to control rover and claw individually. The joysticks are interfaced using Python scripts. We are using 3 Raspberry Pi with Raspbian VC operating system installed. Built-in camera module and a web-based graphical user interface is used to monitor the camera feedback real-time, which can be accessed through a static IP.
For our navigation system, we have used a GPS module which can collect real-time data from 3 orbiting satellites and can be used to triangulate our current position of the rover. We then get the latitude and longitudinal data and plot it on a Google map and on the satellite image. Our software plots a real-time path over the satellite image and also shows altitude and speed of the rover. Our rover has a sensor array component which is used to gather atmospheric data and soil surface data from the Martian environment. From our research, we have found that Martian soil mainly consists of iron dust, sodium, potassium, magnesium and chloride. We have used a pH, temperature and moisture sensor to detect any trace element of life on Martian soil. In our rover sensor system, we also have carbon monoxide which is used to detect any harmful gas which can harm life on Mars.
To complete the science gas task, we have built our own module which consists of 1 actuator and 1 hollow pipe. The first 5 cm of the pipe is as usual and the next 10 cm is slightly cut so that the excess sample can drop out. While the pipe is entered 15 cm into the ground, it can hold the sample from the bottom 5 cm and drop the top 10 cm.